Hey everybody, welcome back to Beyond Basics with Madiha. In today's video, we're going to solve a very important yet an interesting problem. Product of array except solve. Now you might be wondering, why did I choose this particular problem? The reason is pretty simple. If you're preparing for your coding rounds, especially at the top tech companies, and solving problems randomly won't help you. Instead, you need to focus on the questions those being asked repeatedly in the interviews. And this problem, the product of array except solve, is featured in the top 75 LeetCode must-do coding questions. Not just that, it also features in top 100 must-solve DSA problems. So instead of solving problems blindly, the goal of this series is to strategically pick questions that will build you strong foundation and help you crack your coding rounds. So without any further ado, let's dive into the problem. All right, the problem statement is, given an array of nums, return an array of answer such that answer of I is equivalent to product of all elements of nums except nums of I. Let's understand this better with an illustration. We have this input array nums, which includes 1, 2, 3, 4, and the output array has to be such that every element at index I is going to be the product of all elements of nums. That is, all the elements of nums, but except nums itself, except nums of I. That is, excluding in nums of I, it will include the product of all the other elements. Let's understand this further. 1, 2, 3, 4. This is the input array nums. And we're supposed to compute the output array such that we start the array traversal from index 0. Now answer of I has to be, that is answer of 0 has to be product of all elements of nums except nums of 0. Now what is nums of 0? Nums of 0 is 1. And answer of 0 has to be product of all elements of nums. That is 2 into 3 multiplied by 4. And why are we excluding 1? Because the requirement is answer of I, that is answer of 0, has to be product of all elements of nums except nums of 0. So when we exclude nums of 0, we are left with 3 elements. That's why we multiply. We're making use of product of these elements, 2 into 3 into 4, which is going to be 24. This is going to be array of 0, 24. We've got the value at index 0. Now let's try to compute value at index 1. Now array of 1 has to be product of all elements of nums except nums of 1. Now what is nums of 1? 2. Except this, we will multiply all the other elements. That is 1 into 3 into 4, which is going to be 12. That is the value of answer of 1, 12. Now we'll compute answer of 2. Now answer of 2 is going to be product of all elements of nums except nums of 2. Now what is nums of 2? 3. Exclude this, compute the multiplication, the product of all the other elements, which is 8. 1 into 2 into 4. 8. Now nums of 3, product of all elements of nums except nums of 3. Now what is nums of 3? 4. Exclude this. So it will be 1 into 2 into 3, which is 6. That is the requirement. That's the problem statement. We have an array of integers. The output array is going to be such that at every particular index, that is answer of I, includes product of all elements of nums except nums of I itself. Now we've understood the problem statement. Let's understand how do we solve this problem. Now the constraint that's associated to the problem statement, and the constraint is you cannot use division. If you think closely, we can solve this problem making use of this division approach as well. That is, we have the array 1, 2, 3, and 4. Now, if you multiply this entire array, that is 1 into 2 into 3 multiplied by 4, the product is 24. Now, at every traversal, what are we doing? We're excluding the element at index I. That is,
If we start from the very first element, index 0, the array of 0 has to be product of all the elements except array of, that is nums of I itself. Now, when you have to exclude the element from a multiplication equation, what you do is you shift it to the other side. So when you shift it to the other side, it becomes 2 into 3 into 4, and that's equal to 24 by 1. Simple math, which is 24 anyways. So you got array of 0. Okay. Now, likewise, if you look at the same mathematic equation, that is 1 into 2 into 3 into 4. Now, if you don't want 2 from here, you push to the other side. So this time it becomes 24 by 2. Okay, which is 12. 2 ones are 2 twos are, which is array of 1, 12. Okay. Now, likewise, again, if you don't want 3, you push 3 the other side. So whatever element you do not want, you push it the other side, divided by 24, you'll get the answer straight. Okay, but there's one thing that we have to be considerate about. There's one approach. This is one of the approach that we can make use of. But since we have a constraint associated to the problem statement, it very clearly says that we cannot use the division approach. Now, since we cannot use the division approach, there's another approach that we start to think about. That is, or we always start from scratch. That is the brute force approach. Now, brute force approach is again simple. We first start creating the array of answer, as we have to return array of integers, which will hold the product of all numbers except itself. And then we make use of this product because we have to hold the product of the integers. As the brute force includes 2 loops always, we've got an outer loop and inner loop. And we have a condition prefaced here. That is because whenever we do the multiplication, we always have to match the requirement, that is product of all elements except itself. That is why we make use of this condition. Let's understand this with the iteration. This is the array nums with the elements 1, 2, 3, 4. And now we have created an array answer, which is at the moment blank. So this is the array answer of the same length. So this will also store 4 elements. Let's also add the indices 1, 2, 3. And here the indices as well. 0, 1, 2, and 3. Okay, and the product at the moment is 1. So we have the outer loop, I0, pointing at this position. And then we have the inner loop, which also starts at 0. Okay. Now we have to compute the product of the elements. Now this condition, I is not equal to j. Here it is not satisfied. I is equal to j. So what do? We ignore this. We move on. We do j plus plus. Okay. So I is still at 0. J is moved. Now I is not equal to j. Yes, it is not. Therefore, we include this element. Okay. We didn't have to include this element. That is why we introduced this condition. Whenever I is not equal to j, only then we have to include that element to compute the product. If not, we don't need that element. Okay, somehow we excluded this because of the condition. Now 2 will anyways include, because I is at index 0. We have to exclude this, but include all the other elements though. Okay, so product into nums of j, that is 1 into 2, which is equal to 2. So now your product is 2. Okay, and we do j plus plus. I is not equal to j? Yes, it is not. So product into nums of j. See, we are computing the product of all the elements here. So 2 into 3, which is 6. So product is 6 now. Then j plus plus. I is not equal to j? Yes, it is not. So product into nums of j, that is 6 into 4, which is 24. So your product is now 24. And then we end this inner loop. We come out of this inner loop and then we shove or load the answer array. That is now your answer of I, that is the answer of 0 is going to be the product, which is 24. Now, once one traversal is completed, we move back the product to 1. That is, it's no longer 24. It's back to 1. Product is again 1. We again we do I++ now, and we start J again from 0. That is from here. I is not equal to J? Yes, it is not. Since I is at index 1, we have to include 1, right? So that's why your product is 1 into 1, which is anyways 1. Then your J is at this position, that is 1. I is not equal to J? No, it is not. I is in fact equal to J. Both of them are at the same position. So what do? We ignore. We move. We just move the J. J++. I is not equal to J. So now your product will be our product into nums of J. That is 1 into 3, which is 3. So now your product is 3. Then J++. I is not equal to J? Yes, it is not. So what do? Product into J, that is 3 into 4, which is 12. So now your product is 12. Now we got answer of 1, that is 12. Now likewise, we compute the other two elements as well. Again, your product goes back to 1. Your I moves to 2. And your J again starts from 0. Now it will include these two elements, but when it reaches this position, I and J equal, so we got to exclude this. And then we include this element. So once you completed, you will see the product. The answer array is loaded as well. That is, at this position, if you exclude 3, it will be 2 4s are 8. And then when you exclude 4, it is going to be 6. This is how we're going to solve the problem using the brute force technique. But if you look closely in deeper dimensions, you'd understand that it includes 2 loops, okay? Thereby, the time complexity is going to be big O of n square, okay? And the space complexity is big O of n because we need an additional array to store the products. But if you see this time complexity is not optimal, it is not. Since we've got 2 loops, outer loop and inner loop, thereby the total complexity is going to be big O of n squared, which is definitely not efficient for large arrays. Here anyways, the length of the array was small. But in case if the array is huge, vast, then it's going to be a problem. Thereby, we cannot stick or cling to the solution, and hence we optimize the code. Optimized approaches with prefix and suffix. That is, instead of calculating the product again and again, we make use of a very smart trick. And what is that smart trick? We split the multiplication into 2 parts. Now, for every index, we will have to anyways reckon the product. But this time, the reckoning of the product is done in a different paradigm. That is, product is going to be product of elements on the left multiplied by products of element on the right. We'll understand this further in the coming slides with an illustration. Now we have this instance here. We have the array 1, 2, 3, 4. Now for index 2, the value is 3. Now what's going to be the left product of that index? That is, this is the array 1, 2, 3, and 4. And we have the indices 0, 1, 2, 3. Now, if we have to compute the product for the element at index 2, what do? We exclude 3 and we multiply all the other elements, the rest of the elements. But now, if you look at it a little differently, with a different angle, that is, the elements before 3, we assume that to be product of left, okay? And the element right to the 3, we keep that as product of right. So we are splitting the array into 2 parts for every index. Product of left elements multiplied against product of right elements. So product of left elements here will be 1 into 2 since we have 2 elements. And the product is 2. 1 multiplied by 2 is 2. And the product of right, since we only have 1 element here, that's going to be 4. And what's going to be the final product? Product of left multiplied by product of right. Now, product of left here is 2 and product of right is 4, which computes to 8. That's how we deduce the product for every index. All right. Now, let's say we compute it for index 2. Then in that case, we have this element 1, 2, 3, and 4. We again segment this array into two parts. If you're supposed to reckon the product for index 1, that is 2, product of element to the left side versus product of element to the right side. So the left side of 2 is going to be 1, and the product here is 1, multiplied by the right side product. So right side, you've got two elements, 3 multiplied by 4, which is 12. Hence, the final product is going to be 12. So this is the concept and this is the logic behind the optimal solution. What are we doing? We are segmenting the array. We are breaking the array into two parts and then we compute the left product, right product, and at the final section, we multiply left product multiplied by right product. That's going to give us the final answer. Now we've understood how we are doing it, but let's also understand how we are coding this optimized solution. Okay. So step 1, we first calculate the prefix. Now the prefix and suffix is the new terms that you will understand here. For left products, we're going to call prefix, and for the right products, we're going to call suffix. Okay, prefix means product of all elements before the current index. So if you have this array, 1, 2, 3, and 4. So prefix of 3 is going to be the product of 1 and 2. Okay. And prefix of 2 is going to be the product of the elements before 2, that is 1. Prefix of 4 will be the product of elements that comes before 4, that is 1, 2, and 3. That's how we calculate prefix. The left side product is usually termed as prefix here. Okay, so here what are we going to do? We're going to have a prefix array, an array that includes the prefixes. That is, at index I, all the prefix of that particular number. At index 1, the prefix of 2. At index 2, the prefix of 3. Okay, something of this sort. Let's try to understand this further. Now the prefix array is going to be something of this kind. How do we get this array is at index 0, that is, let's say if this is the array, 1, 2, 3, and 4. So that is at the index 0, which is at 1. What do we have? We don't have any prefix. We don't have any elements before 1. Therefore, the prefix itself is going to be 1. Now we move on at index 1. So what are the elements before 2? There's only 1. So 1 multiplied by 1 is anyways 1. That's why we see 1 and 1 in this area, okay? Let's also put the prefix right in here. Now we move to at index 3. So at index 3, the elements before 3, that is 1 and 2. Now you have to multiply these elements. 1 multiplied by 2, and that's going to be 2. That's why you have 2 here. Now prefix of 4. Prefix of 4, elements, all the elements before 4. That is 1 multiplied by 2 multiplied by 3. Which is 6. This is the prefix array. Step 1 is going to be forming the prefix array. That is this, the prefix array. Now, once you get the prefix array, we calculate the suffix array. That is product of elements to the right side. So suffix implies product of elements after the current index, whereas prefix before, prior to the current index. Now, if you see the suffix array, it is 24, 12, 4, and 1. Okay, that is, let's say if this is your array. Now, suffix of this will be all the elements to the right side. That is 2 multiplied by 3 multiplied by 4, which is 24. Likewise, suffix of 2 is going to be all the elements to its right side. That's how we compute the suffix. But here, if you see, this is equivalent to the answer array. Why? Because we are not again making use or creating a new array to hold suffix. We make use of the same answer array so that we do not have to store another array. We can compute it from left to right. For now, understand it this way. That is in the answer array itself, we're going to include the suffixes, okay? Now, how do we do that? We'll look into the future slides. Okay, here is the code. Let's understand the code. We've got nums. We are calculating the length n. Then we're creating a new array result to hold the product of all the elements except itself, the final result array that you'll have to return. Then we have only one loop here, thing to notice, okay? In the brute force, we've got two loops, outer and inner. Here in case, we've got just a loop. We start with I equals 1, I less than n, I plus plus. Now, what are we doing? Step 1 was calculating the prefix, okay? So, if this is your array, 1, 2, 3, and 4. Now, one thing you have to notice here is we are starting with I equals 1. Why? Because prefix of 1 is anyways 1. We don't know, because we don't have any elements before that. So you can ignore this element and you can start from I as 1. So these are your indices, 0, 1, 2, and 3. So we start from I is equal to 1. And what are we doing here? Understand how we reckoning the prefix. Okay, one more thing before this is result of 0, we are setting it to 1 anyways. Okay, so this is your result array, which will have 1. Okay, and here the indices are 0, 1, 2, and 3. We start with index I, which is at 1. Now we have to calculate the prefix array. Okay, and how are we doing the prefix array? All the elements before it, we are multiplying the elements, right? So it is going to be result of I minus 1 into nums of I minus 1. So result of I minus 1 is anyways 1, right? Result of 0. I is 1, 1 minus 1 is 0. So result of 0 is 1. 1 multiplied by nums of I minus 1. Now what is I? I is 1. Again, 1 minus 1 is 0, which is this. This is just a generic starter because we will have to manage the condition wherein at the first position there is no prefix to be calculated. That is why we introduce 1 and we start from 2. Now if you take 2, we are not including this element. This multiplied by 1 anyways, okay? Because always the product, we always initiate it with 1. That is why it is going to be result of I minus 1 multiplied by nums of I minus 1. Why I minus 1? I minus 1 here is because result of I minus 1 only is going to give you the first element, that is 1, that we always initiate the product as well. If you remember in the previous slides as well, always we started the product to be 1. In multiplication, the initialization must always be 1. Okay, that is why 1 here. Now we have to calculate the prefix for 2. You need to calculate it from I minus 1 only, right? It will always be I minus 1. That's why it is I minus 1 here. So 1 into 1 anyways is 1. Therefore, this is going to be the prefix value. And we move on. I plus plus. Now this is your I. Now what do we do for prefix of 2? That is prefix of 3 will be elements before it. That is 1 and 2. Now how are we doing that? Again, result of I minus 1. That is prefix of this. We already know, right? We multiply it with nums of I minus 1. That is going to be 1 into this element. That is 2. 1 into 2 is going to be 2. Then we do I plus plus. Now you have 4. Now here all the elements. So all the elements we already have prefix of this. Till here we know. We have to multiply this so that we get the prefix for 4, right? So 2 into 3. That is nums of result of I minus 1, which is 2, multiplied by nums of I minus 1, which is 3, 6. And we got our prefix array. Now we understood, we have computed the left products, that is the prefix, and we are not creating an additional array. Rather, we are making use of the same result array that we'll have to return so that we balance the space complexity with time complexity. Now we're done with computing this prefix. Now let's jump over suffix. Okay. So now your suffix, we start from the opposite of it. Now let's just have the array again. This is nums 1, 2, 3, and 4. Okay. This is your nums. And now we have the result array as well, which is holding the prefixes. So prefix of this is 1, prefix of this is 1, prefix of this is 2, prefix of this is 6. Now we need the suffixes. Now suffixes, we again start the suffix with 1, but there's one thing you'll have to notice is, here we are starting from n minus 1, that is from here. Okay, at both the places we are starting from here. Why so? If we start from here, then we again have to create another array, a fresh array, and hold the suffixes, which will increase the space complexity, right? In order to cut down the space complexity, to optimize the space complexity, we're making use of only a variable here, that is suffix. Okay. The array, we manipulate the same array. On the fly, we are computing the product that is left into right, and then we are storing it just like this. Now let's see the traversal though. So your I starts from here, that is n minus 1. Okay. And you're doing result of I, that is the same array, we modify and return it. Okay. So result of I is going to be result of I into the suffix. Now till here, if you see, this is the prefix of 4, right? This is the prefix of 4. Now what suffix means? Elements right side to 4. Do you see any elements right side to 4? You don't. That's why here suffix we start with 1, just like how we did result of 0 as 1. Same ways we're doing suffix as 1 because we don't have any other elements here. We already know the prefix, there's no element, so suffix is 1. Thereby result of I, that is 6. This is the left product. Right, there's nothing. That's why we put as 1. Okay. Into suffix. So 6 into 1 is 6. So this is going to be your result of I, which is already this 6. Okay. And then you will change your suffix. Each time your suffix is going to be suffix into nums of I. Now let's understand this clearly. Why are we modifying is, we have the prefix stored in the array, but we do not have the suffixes stored. If we move backwards, that is from the opposite direction, we can hold a suffix in this variable. Now, suffix was 1 because there was no element after 4. But if you go to 3, you will have an element after 3, that is 4, right? Therefore, the suffix will now be whatever suffix it already has, that is 1, into nums of I. That is 4. Therefore, the suffix of 3 is nothing but 4. Whatever elements you see after 3 is going to be the suffix for 3, right? The product of those elements. Same as what we are doing here. Now your suffix is what? Your suffix is 4. And we do I minus minus. Now this is your I. This is your I. Now what are we doing here? We already have the prefix for this, that is 2. Now we are supposed to multiply it with the element next to it, that is 4. We already have 4 stored in the prefix. So therefore, what do? Result of I into the suffix, that is, what is the suffix? 4. And what is the result? 2. So 4 into 2, which is going to be 8. So result of I is now going to be 8. Okay, and we again update the suffix. Now, what is your suffix going to be? We should now have the suffix for 3. We had the suffix for 3. That was 4. Now we should have the suffix for 2. So it will be suffix, that is 4 into nums of I. That is this 3, which is 12. Now your suffix will be 4 into nums of I, which is 12. This is your updated suffix. At every iteration, we are calculating the suffix for the previous element. Okay, suffix for 2 was 3 into 4. That is what we've calculated because we already have the prefix for this. So prefix we've got, suffix we've multiplied, we are computing the value and we keep going further. Okay, now this is your I. Now your I is at this position. And what are we doing here? We are doing result into the suffix. So what is result of I? 1. Into suffix is going to be 12. So this will be 12 now. And what is the suffix? Now we have to calculate the suffix for this. So it will be 2 into nums of 5. Sorry, 12 into nums of 5, which is 24. That is how your suffix is going to be. Now again, I minus minus, this is your I. Result of I into suffix, that is 1 into 24. This will become 24. And what is your suffix now? Your suffix will be suffix into nums of I. That is 24 into nums of I. Anyways will be 1. So it will be 24 only. And then we do I minus minus. We come out of the loop. We return the result. Now if you see, this is the result. 24, 12, 8 and 6. Okay. We'll understand this better as we move on and code the solution on our own. Okay. For now, one quick revision is going to be, we compute the prefix, then we calculate the suffix from backwards. Okay, on spot, that is on fly, we're going to calculate the suffixes and then we return the result. So in the same result, we are storing the prefixes. And then as we move backwards from the opposite direction to this result array, we on the fly compute suffixes. Because we already have prefixes, so it's very easy to calculate suffix if we move from right to left. Because at this position, you know what is the prefix. So for suffix, you only need 1. You only need to multiply it by 1. Now at the second penultimate position, you already have the prefix. Now suffix will be, you already know what value you have here. Just multiply it with that. And update the suffix. Store the value there so we can use it further. Now again, when you see here, you already have the prefix. You already have the suffix here, multiplication of 2 elements. So you compute and then you update the suffix because you include this element also in the suffix. It's just the same. Solution. We've got integer of array nums. We're supposed to return integer of array of integer, product of all the elements except self. So let's first create the answer or the result array. And that's going to be the same size of nums. Okay. And now we need the suffix. Okay, let's start with prefix first. And we're making use of the same array to hold the prefixes of the elements. So result of 0 is anyways going to be 1. Now why 1? Because the element before 1, it has no other element. So its prefix will always be 1. Now let's start loading the prefixes. So for int I equals 1, let us start with index 1 because for index 0, we've already set the prefix is 1. Okay. I value has to be less than nums.length. I value less than nums.length I plus plus. Now how are we computing the prefix? The result of I has to be result of I minus 1. Its previous value, we multiply it with nums of I. Nums of I minus 1. Yeah, that's how we're going to calculate the prefix. Now this is going to be something of this kind. If you have the array 1, 2, 3, and 4, this is your nums. And your result array, anyways, result of 0 is 1. So result of the next element, that is this, the prefix of 2 will be product of elements before 2, that is 1. That is why we need nums of I minus 1, which is this value. And we are multiplying it with, already we have the prefix for the previous elements. That's why result of I minus 1. Okay. All right. So that's going to be result of I equals result of I minus 1 into nums of I. This is how we calculate the prefix. Now, once we've calculated the prefix, we go to suffix. Okay, let's say int suffix is going to be 1. And here we start with parent I equals nums dot length minus 1. I must be greater than or equal to 0. I minus minus. Now, if you make use of this calculation, you already have your prefixes stored with the help of this code. That is, for 1, it's going to be 1. For 2, it's anyways 1. And prefix of 3 is 2. Prefix of 4 is 6. This is your result array at the moment. Now we are starting suffix. Your suffix is anyways 1. And we are starting to traverse backwards. This is your I. Nums dot length minus 1. Now we already have, now we have to calculate the product of this element except itself, right? We have the elements to its left, that is its prefix is already there. And there are no elements after it, that is why the suffix is 1. Therefore, your result of I will be equal to result of I multiplied by nums of I. Okay? A moment. You can make use of your suffix, not nums of I. Okay, that is result of I anyways is 6. That is this element multiplied by suffix, which is 1. So if you see, the product of this element has to be all the elements to its left and to the element its right. To the element its left, we already have that is 6. To the element its right, there's nothing. There's 1 only. So that's why it is result of I into suffix, which will be 6. But there's one thing that you have to do, that is you update the suffix. Now your suffix has to be, that is, the suffix for this was 1. Now when we move forward, we have to calculate the suffix for this. Now the suffix for this will be the suffix which is already there multiplied by nums of I. Before you decrement, calculate the suffix, which will be going to be suffix into nums of I. Each time we update the suffix. Okay, and finally, once we are done computing, we return the result. Simple. Let's try to submit this. So we've missed a bracket, I believe. So let's introduce a bracket and then try submitting. Okay. This is the optimized solution. I hope the solution is clear. We calculate the prefix, then we compute the suffix, and then we return the result. Now, if you see the time it takes us 2 milliseconds, beats 94.50% of solution. The memory usage is lesser as well because it's only big O of 1. We only use a variable, an additional variable. Rather, everything remains the same. Okay, and time complexity is big O of n. All right, this brings us to the end of the video. Let me know if you had any doubts in the comment section. I shall respond and clear your doubts as well. This brings us to the end of the video. If you found something knowledgeable, then do like, share, and subscribe to stay tuned. And we shall see you on the next video of DSA.